All right, this video is 4.5b about tree diagrams. So yesterday we talked about the general multiplication rule, and we're going to use that today as we do tree diagrams. Here's the first scenario. Shannon hits the snooze alarm on her alarm 60% of school days. If she hits the snooze, there's a 70% chance probability that she makes it to her class on time. If she doesn't hit the snooze and gets up right away, there's a 90% chance probability that she makes it to class on time. Shannon hits the snooze button on her alarm on 60% of school days. If she hits snooze, Shannon hits the snooze button on her alarm on 60% of school days. If she hits the snooze, there's a 70% probability that she makes her way to her first class on time. If she doesn't hit the snooze and gets up right away, there's a 90% probability that she makes it to class on time. Suppose we select a school day at random and record whether Shannon hits the snooze button and whether she arrives on class on time. So we use a tree diagram to show this process. All right, so first of all, the first decision is, does she hit the snooze button? So we have a snooze button and doesn't hit the snooze button. All right, so we know that there's a 6% chance that she hits snooze. That means that what's left? There's a 40% chance she doesn't. Okay, and then the question further gives us more information. It says if she hits snooze, so we're talking past this point now, there's a 70% probability that she makes it to class on time. So that's where I get the 0.7 right here. Then if she's on time 0.7, that means she's late 0.3. Okay, the problem doesn't state that, but we know these two have to add up to 1. Then it says if she doesn't hit the snooze, so we're down to this bottom box, and gets up right away, there's a 90% probability that she's on time. So if she's on time 90%, that means she's 10% of the time late. So you can see how we built that tree diagram. Now we can use this to answer some questions. All right, so write this down. A tree diagram shows the sample space of a chance process involving multiple stages. The probability of each outcome is shown on the corresponding branch of the tree. All probabilities after the first stage are conditional probabilities. All right, what does that say? All it says that everything back here, okay, this is the first stage. So everything back here is conditions. Okay, those are the conditions on the original. All right, so here's the question. What's the probability that Shannon hits the snooze button and is late for class on a randomly selected day? All right, so we know she hits the snooze button based on the problem. So we can go down this path and is late. So we come down here. We go this way. Now, our probability rule we used yesterday means we would just multiply these two. 0.6 times 0.3 gives us 0.18. All right, so that's easy enough. Probability that she hits the snooze button and is late. We just follow the tree and multiply the two probabilities. All right, so now what's the probability that Shannon is late to class on a randomly selected day? There's two ways that this can happen, though. It doesn't say she hit the snooze button in this problem. It just says she's late. All right, so there's two ways it can happen. In the red, it's marked. She can hit the snooze and be late, or she doesn't hit the snooze and can be late. All right, so there's two ways it can happen. So we have to consider, if they ask us about the probability of late, we have to think about the two ways it can happen. All right, so some interesting conditional probability questions involve going in reverse on the tree diagram. For instance, suppose that Shannon is late for class on a randomly selected day. What's the probability that she hit the snooze? So we can use the information from the tree diagram and the conditional probability formula to do the required calculation. All right, we already stated this part right here, that if she's late, that means we've got to consider she hit the snooze, she didn't hit the snooze. There's two ways she could be late. All right, our probability formula for a given probability, remember whatever's on the back end of the statement, that goes in the denominator. And the and version of it goes in the numerator. So we hit snooze and late. All right, so to find our values for snooze and late, we hit the snooze, follow the tree. Hit the snooze and late, we multiply those two. That's what we did right here. Okay, And previously we found that value to be 0.18. The denominator is just the probability that she's late only. So like we said before, you got to think two ways that happens. So she hits the snooze and she's late. That's the point. That's this part right here. Plus, she doesn't hit the snooze and she's late. So you multiply those two as well. And then you add those two possibilities, and that gives us 0.22. Once you know those two, then you divide them and you get 0.818. All right, let's try one of these. In a recent month, 88% of automobile drivers filled their vehicles with regular gasoline. 2% purchased mid-grade gas, 10% bought premium. Of those who bought regular, 28% paid with a credit card. Of the customers who bought mid-grade and premium, 34% and 42% respectively paid with a credit card. Suppose we select a customer at random. So the first thing you're going to have to do today is draw these tree diagrams, but I've drawn this one for you so you can see how these all lay out. All right, so hopefully it makes sense to you. You might just pause the video and see if you can draw the diagram without looking at my answer, just for practice, okay? Now, draw the tree diagram to see the model. There it is. That's the first thing you got to do. Now, B says find the probability that the customer paid with a credit card. All right, notice it doesn't tell us what kind of gasoline they got. So we've got to think about every possibility of paying with a credit card. So they could have paid regular with a credit card, mid-grade with a credit card, or premium with a credit card. So we have to think through all three of those, okay? So the probability paid with the credit card. So I first do the regular gasoline. I'll say 0.88 times 0.28 plus 0.02 times 0.34 plus 0.10 times 0.42. Okay, so I'm going to put those in my calculator and see what I get. And I get 0.1832. All right, 0.1832, that is a 2. Sorry, my pen is not good. All right, so notice you had to think through all three possibilities here for credit card alone. All right, now back to our Gump chocolate. According to Forrest Gump, life's like a box of chocolates. You never know what you're going to get. Suppose a candy maker offers a special Gump box with 20 candies that look alike. In fact, 14 of the candies have soft centers, 6 have hard centers. So we draw a diagram to depict what's going on here. Okay, so sometimes you don't have decimals, you have fractions. So we know 14 out of 20 are soft, 6 out of the 20 are hard. Now the second branch is the second piece drawn, right? Second piece of candy. So once I've drawn one piece of candy, that denominator goes from 20 to 19. If I drew a soft first, that means I only have 13 soft left, and I have all 6 hard candies left. If I drew a hard candy first, then I'm down to 5 hard pieces of candy left, and all 14 soft centers. Okay, so that's where we get all this. So B, find the probability that one of the chocolates has a soft center and the other one doesn't. All right, so you got to think through your diagram. One has a soft center, one doesn't. So this would be soft center, and then this would be the hard center, right? And the other way that this can happen is if I pick a hard center candy first, and then I get a soft center candy. So then I need to calculate these probabilities. So I'm going to do 14 out of 20 times 6 out of 19 plus, then I come back and I'm going to do hard candy, then soft candy, 6 out of 20 times 14 out of 19. All right? So I'm going to calculate these on my calculator and get you an answer. All right, so I get the answer 0.442. Okay, 0.4421 if you want to go to 4 decimals, at least 2 decimals. Okay, so that's my probability. I have to think through both possibilities here. All right. So I'm going to give you a worksheet today where you work on these and